The modern U.S. Carrier Strike Group represents one of the most complex organizational and engineering achievements in maritime history. It is often described colloquially as floating diplomacy or projected power, but operationally, it is a self-contained industrial ecosystem designed to function indefinitely at sea. The formation consists not merely of a single aircraft carrier, but of a tightly integrated network of surface combatants, submarines, aircraft, and logistical support vessels moving in unison. To understand how it operates requires looking past the spectacle of flight operations and examining the intricate web of maintenance, communications, and command structures that bind these assets together. A strike group does not simply react to events. It shapes the environment around it by creating a moving bubble of sovereign territory that extends hundreds of miles in every direction. At the center of this formation sits the nuclear-powered aircraft carrier, typically a Nimitz or Gerald R. Ford-class vessel. It serves as the flagship and the primary airfield, but its operation is dictated by a rigid, unyielding rhythm known as the flight cycle. This cycle determines every other activity within the strike group. Operations on the flight deck are choreographed to the second. The deck is not merely a runway. It is a puzzle of geometry and timing where dozens of aircraft must be fueled, armed, launched, recovered, and parked within a confined space. The movement of aircraft is governed by the Ouija board, a physical or digital model in flight deck control that tracks the status and location of every airframe. Handlers on the deck, identifiable by their color-coded jerseys, communicate through hand signals as the noise level renders voice communication impossible. The purple-shirted fuel handlers, red-shirted ordnance crews, and yellow-shirted aircraft directors work in parallel, often while the ship pitches in rough seas. The launch process relies on steam or electromagnetic catapults to accelerate a 30-ton aircraft from a standstill to 150 knots in under 3 seconds. This is not an automated process. It requires human verification at multiple levels. The shooter, an officer positioned in a bubble on the flight deck, calculates the weight of the aircraft and the wind over the deck to determine the precise energy required for the launch. Simultaneously, pilots must verify their engine instruments and flight control surfaces. Once airborne, the aircraft enters the strike group's airspace, but the work on the deck shifts immediately to recovery. Landing a high-performance jet on a moving ship remains one of the most demanding tasks in aviation. The pilot aims for a specific wire among 3 or 4 stretched across the deck. The ideal landing catches the number 3 wire. If the pilot misses all wires, a bolter, they must immediately apply full power to take off again. This requirement to go from idle to full military power upon touchdown adds significant stress to the airframe and the pilot. However, the carrier is only the hub. Its survival and effectiveness depends entirely on the defensive ring that surrounds it. This screen typically includes at least one Ticonderoga-class cruiser and several Arleigh Burke-class destroyers. These ships are not merely bodyguards, they are specialized sensor platforms. The cruiser usually serves as the air defense commander for the strike group. Its primary tool is the Aegis Combat System, centered around the SPY radar, which can track hundreds of airborne targets simultaneously, from sea-skimming cruise missiles to high-altitude ballistic threats. The cruiser coordinates the air defense picture for the entire group, assigning targets to other ships or aircraft as necessary. This delegation is part of the Composite Warfare Commander concept, which distributes authority based on function rather than rank. While the Admiral commands the entire group, the cruiser captain manages the air war, and a destroyer squadron commodore often manages surface and subsurface warfare. The destroyers are positioned to maximize radar coverage and sonar capabilities. They act as the shield against surface ships and submarines. Modern naval warfare assumes that threats will arrive in salvos, swarms of missiles or drones designed to overwhelm defenses. To counter this, the escorts utilize a layered defense strategy. Long-range interceptor missiles engage threats at a distance, medium-range missiles handle leakers, and close-in weapon systems such as the phalanx or ram launchers provide a final, desperate line of defense. This layered architecture requires constant data sharing. Through systems like the Cooperative Engagement capability, a destroyer can fire a missile at a target it cannot see using radar data provided by an E-2D Hawkeye aircraft flying overhead. This networked approach expands the defensive horizon far beyond the curvature of the Earth. Beneath the surface, the strike group includes an attack submarine, usually of the Los Angeles or Virginia class. Unlike the surface ships which operate in visual formation, the submarine operates independently, often miles ahead of the carrier. Its primary mission is sanitization, sweeping the ocean for hostile submarines that might threaten the high-value units. The submarine utilizes passive sonar to listen for the acoustic signatures of other vessels, thermal layers in the water column, and biological noise. It operates under strict rules of engagement and communication protocols to avoid blue-on-blue incidents. The submarine is the silent partner. The strike group commander may not know its precise location at all times, but relies on it to clear the path. The effectiveness of this combat power is entirely dependent on the carrier air wing, which has evolved into a mix of strike fighters, electronic warfare aircraft, and airborne early warning platforms. The backbone remains the FA-18 Super Hornet or the F-35C Lightning II. These aircraft are multi-role, capable of shifting from air-to-air combat to precision ground strikes within a single sortie. However, the unsung workhorses are the support aircraft. The E-2D Hawkeye, with its distinctive rotating radar dome, serves as the quarterback of the sky, managing the airspace and providing target data to the fighters and surface ships. The EA-18 Growler provides electronic attack capabilities, jamming enemy radar and communications to allow the strike aircraft to operate in contested environments. Helicopters, primarily the MH-60 Seahawk variants, conduct anti-submarine warfare and search and rescue missions, flying perimeter patrols day and night. Sustaining this floating city requires a massive logistical effort, anchored by the Fast Combat Support Ship or Fleet Oiler. A carrier strike group consumes hundreds of thousands of gallons of aviation fuel and marine diesel every few days, along with tons of food and ordnance. The process of replenishment at sea, or RAS, is one of the most dangerous seamanship evolutions conducted by the Navy. The supply ship and the receiving ship must steam alongside each other, often separated by less than 200 feet, while maintaining precise speed and heading. Fuel lines and cargo pallets are transferred via tensioned cables strung between the vessels. This dance occurs regardless of sea state or visibility. A steering casualty or a sudden shift in wind during a RAS can lead to a catastrophic collision. The supply ship acts as the strike group's tether to the global supply chain, shuttling between the formation and friendly ports to keep the magazines and fuel tanks full. Command and control of this enterprise takes place in multiple centers. The admiral and their staff work from the flag bridge or a dedicated war room, focusing on the strategic and operational picture, where the group is going and what its overall mission is. The captain of the carrier, distinct from the admiral, focuses on the ship itself, its navigation, reactor safety, and flight deck efficiency. Deep inside the ship, the Combat Direction Center fuses data from all sensors. Here, young officers and specialists stare at glowing consoles in a dark, chilled room, identifying every blip on the radar and classifying it as friend, neutral, or foe. The cognitive load in this room is immense. Decisions to engage a target must often be made in minutes or seconds based on electronic signatures and intelligence reports. The rules of engagement are strictly codified, but the fog of war introduces ambiguity that human judgment must resolve. This human element of the strike group is defined by endurance and repetition. For the 5,000 to 7,000 sailors spread across the formation, life is a cycle of watches, maintenance, and drills. On the carrier, the day is effectively 24 hours long. When flight operations cease for the night, or day depending on the schedule, the maintenance crews descend on the aircraft. Engines are swapped, avionics are tested, and hydraulics are patched. This work is performed in hangar bays or on the windy flight deck, often in extreme heat or cold. The average age of the crew is typically under 25. These junior personnel are responsible for maintaining nuclear reactors, handling high-explosive ordnance, and interpreting complex sensor data. The hierarchy is rigid, but the reliance on technical expertise means that a junior sailor often holds the authority to halt an operation if a safety parameter is violated. Strategic mobility is the strike group's defining advantage. Unlike a land airbase, which is fixed and requires diplomatic clearance to operate, a carrier strike group can move 500 miles in a single day. This mobility complicates the planning of potential adversaries. A group operating in the Philippine Sea one week can be off the coast of the Korean Peninsula the next. This movement is not random. It is calculated to demonstrate resolve or provide options to national leadership. The transition from presence operations, simply being there, to combat operations can happen almost instantly. During transit, the group may practice emissions control, or econ, turning off all radars and radios to disappear electronically. In this state, the ships communicate via flashing lights or visual signals, navigating silently to avoid detection by satellites or electronic eavesdropping. The integration of the air wing with the surface ships extends to the concept of the kill chain. In modern naval doctrine, the platform that fires the weapon is not necessarily the one that detects the target. An F-35 might detect a hostile ship using its passive sensors and data link that information to a destroyer, which then launches a long-range missile. The aircraft effectively acts as a forward observer for the surface fleet. This synergy requires robust, jam-resistant data networks. If these networks are degraded by enemy electronic warfare, the strike group must revert to pre-planned tactics and decentralized command, relying on the initiative of individual ship captains and pilots to execute the commander's intent. Maintenance of the nuclear propulsion system is another critical, although less visible, component of operations. The carrier's reactors allow it to steam at high speeds for 20 years without refueling.
This provides the tactical advantage of being able to outrun bad weather or close distances rapidly. However, it imposes a strict culture of nuclear safety. The engineering department operates in a separate world deep within the hull, monitoring pressures and temperatures with obsessive precision. The ability to generate massive amounts of electricity is what allows the carrier to power its radars, catapults, and command systems. The surface escorts powered by gas turbines do not have this unlimited range and must carefully manage their fuel consumption, necessitating the frequent rendezvous with the supply ship. The strike group also plays a significant role in humanitarian assistance and disaster relief. The sheer capacity of the carrier to generate fresh water, hundreds of thousands of gallons per day, and the lift capability of its helicopter squadrons make it a potent first responder. In the event of a tsunami or earthquake, the focus shifts from combat sorties to logistics. The flight deck becomes a staging area for pallets of rice and water. This dual-use capability highlights the flexibility of the organization. The same command structures used to coordinate airstrikes are repurposed to coordinate relief supplies. The transition requires a mental shift for the crew, but the fundamental processes of logistics and air traffic control remain the same.
While we have explored the daily operations, the full scope of the strike group extends much further, encompassing the grueling months of pre-deployment training, the high-stakes legal complexities of freedom of navigation operations, and the rapidly evolving integration of unmanned systems. For a detailed breakdown of these three critical elements, please consult the analysis provided in the description below. Ultimately, the carrier strike group operates as a system of systems. No single ship or aircraft is self-sufficient. They rely on the protective bubble created by the others. It is a balance of offensive power and defensive vigilance, maintained 24 hours a day. The complexity of this operation is such that few other nations attempt it. It remains a definitive expression of maritime strategy, a mobile airbase capable of influencing events on land from the international waters of the sea.